Alright guys, let's go ahead and get this started. So this is going to be a shorter video, kind of impromptu. Um, Unity's game server and multiplayer, matchmaking service went live about a month-ish ago. And apparently there's like no information about these services anywhere on YouTube. So I'm decided to throw my hat in here and just give a quick rundown on how all this kind of works. There is a GitHub repo that has a MultiPlay matchmaking project in it that kind of shows just the bare basics of a project running with the Netcode for game objects and matchmaking and getting a server all built up. So I guess the first thing is, what even is this? So as it says here, this is their game server hosting, formerly maybe continuing being known as MultiPlay. This was a service that Unity bought 5-ish years ago. I think around the time they bought MLAPI, honestly. But this is just a regular old server hosting platform that has been in closed beta for a while, but has recently opened to the public, so we can spin up our own servers for our own projects. I believe Among Us and not Valorant, Apex Legends use MultiPlay, and also Vivox is the voice chat service that they use. Won't go into that just yet. Maybe save that for a later one. So this here is the Unity dashboard for all of Unity gaming services. That includes all of the analytics, the DevOps, cloud build, whatnot, live ops for the like in-game economy, cloud code, cloud save, player authentication. We'll get into a little bit of authentication here. Your growth, which is like your ads, user acquisition platform is in here. Well, I guess that's the ads. Growth is more analytics and stuff for that. Monetization for ads, but we'll be focusing on multiplayer. I've did a thing on Relay and Lobby before, so you can check out the past videos for that. They're all up on YouTube. This will be on YouTube as well. So the first thing that you'll do here is you do need to come to the dashboard first, basically before you do almost anything else. You can choose a project. Which projects? We just check this one out. So the first thing you do is you'll set up MultiPlay. You'll need to enter a credit card for payment information, but once you do that, that'll be active for all of your projects. Then once you enable it, you can start through this setup guide, which I've done, but I can reset here. This doesn't actually break anything, but you'll see this setup guide, and this will kind of walk you through getting initially set up here. And we'll just walk you through this MultiPlay server hosting does not have to be with Unity, so you can actually use Unreal eventually, it's coming soon, or any other custom engine that you want to run. But for now, it's Unity only. Then the next thing you'll do is you'll go into actual Unity, set up your services, which is here in the project settings. Project settings, services here. And you'll just link a project here. You can create a project first, and link it, or you can create it from actual Unity. Then the next thing you do is just install the package from the package manager, and it's just com.unity.services.multiplay. This should actually just be straight up in the package manager, but I think that might still be in preview. Okay, so we got that. Next, we create a build. Now I'll go through a bit of the code. The actual GitHub is here. Where? Here. Yoink. It's here. Just Unity Technologies, com.unity services, samples, MatchPlay. It also has a quick rundown on how to get this server up and running. This is what we'll be kind of be going through most of this real quick. All right. So once you actually get this project open, it has a couple of editor scripts in here. This is not a learning project. I wouldn't say that it's over-engineered like some of their other projects they've had, but it's definitely not a bare bones just to get started project here. It's got some built-in editor tools for building clients and a Linux server. Right now, MultiPlay only works with Linux. I'll show you here in a second. Windows support for Windows servers are coming in a future update. But this is just a little editor script that will automatically build to these different platforms for you, or you can just build them all. Another thing that is super duper helpful when developing multiplayer is this separate little project called Parallel Sync, not Parallel Sync. It's Parallel Sync, and it's just a third-party GitHub repo that this will clone your project so you can run two projects at the same time. So you can have one being a server, one being a client. You can add multiple clients, run them all at the same time, and each client will authenticate as its own user, which is important. Okay, so once you build out your server here, I've done this ahead of time, you will get this folder here. And this folder is everything that you need to actually run your server up on the cloud. Other services like PlayFab will require you to zip up all these files. This explicitly does not. So what we can do is we'll go ahead and create a build. I'm not going to just yet. Well, might as well. We'll just call this test. Yeah, that. Test. Okay, you can upload it as a direct file or as a container. If you have a Docker image that you want to upload, you can do it that way. I think there is a limit for direct file upload. I think it's like 4 gigabytes. So if you've got super huge servers, you'll have to containerize it first and then upload it. Or I think there's a REST API you can use for command line uploading images. So here we will just take our thing. We don't need our debug folder here, and just drop it in there. Bloop. Upload. It doesn't take too long. Server is incredibly tiny. It does not do much. Okay. Next, text version, yada yada, finish. All right, and then the next thing we'll do is create a build configuration. So the build configuration is basically how the executable will actually run. And just call it test config. Naming things is hard. And whatever, these are both the same. It doesn't matter. The game executable is the x86 file here. So the query type, this is how MultiPlay will communicate, or how your client will communicate with the actual server service. So there's a couple of ones you have here. We'll be doing the SQP, which is what MultiPlay uses. You can actually run the Steam SDK. This is the A2S here. If you want to query through like Steam. So I guess if for the Steam like serverless and stuff like that. And the launch parameters, this will be the ports and the IP address. These $sign variables will get supplied by MultiPlay. So just leave all those default. The logs will show you in a second here. Leave all that default, that's good. Actually, it probably could call, what is it, no graphics? Doesn't really matter. I don't want to break everything. But here you would, like, you could put, like, batch run, and I think it's no graphics. And, like, batch run, I think is for servers. We'll test that. We don't have any configuration variables here. So the usage settings, this is going to be super important here. For this should be set as whatever your server will be consuming CPU speed and memory speed wise. This is super important because this is what you will actually be spending when a server spins up. Here in the prices, which is something we probably should go over sooner than later, is seeing. Okay, so before we move on, we'll cover some pricing. So these are just straight up from the docs. docs.unity.com/game server hosting. These, it's all pay as you go. So when you first start out, they will give you $800 in credit up front for the first 6 months that you're signed up. And this is across your whole account. So if you have multiple games running multiple servers, you get charged from the single account, no matter how many games you've got going. The specifics here are all a little bit different. You have per CPU core and also per gigabyte per hour for your RAM. And your license type, Linux is free. Windows is 4 cents an hour or whatever, which doesn't matter because we can't actually run Windows at the moment. The prices here in on the documents page apparently is all Asia locations, the Asia region. I'm not quite sure why. Yeah, I don't know why. The other locations, you can't choose them. or whatnot, but they're all roughly the same. Down here below in some of the samples here, you'll see examples of what a computer with like 2 cores, 8 gigs of RAM, and a Windows license would run you per hour here. You do get charged storage, which is, I believe, the storage of the server, like executable, per month. I think that is up to yeah, I think it's for the first 50 gigs. Or I might be thinking of PlayFab. And also the bandwidth. So the bandwidth is the amount of bandwidth coming out of the server, not what is actually going into the server. So they don't charge you for incoming bandwidth, just the outgoing bandwidth from the actual server. So these are some of the example prices for running, like when you're testing this out. If you run your tests, 3 hours a day, 5 days a week, this is kind of what you'll end up seeing here. Roughly what, $15-ish per month. And this is with one machine in the US East, one machine in Europe, for 2 cores or 2 CPUs, and also 8 gigs of RAM, running Linux. Linux is free, whatever. Same for the storage. If you got 15 gigs on US East and Europe West, $3. So all told, about $23. It's not too bad. The scale testing, this is kind of like when you go live, right? So they've kind of planned it out so that $800 will get you a month, like at scale. I guess moderate scale, right? So this is 2 machines, 2 cores running all month, 730 hours, 24/7. 2 machines, 8 gigs of RAM each. And this is 2 machines in US, Europe, and Asia. And that is roughly 6 gigs of storage each. And they are estimating like half a terabyte each per month for your bandwidth. So that's outgoing traffic. Your mileage will vary, so that's just something to keep in mind. So yeah, we can take a quick comparison to PlayFab. Let's see. Look at this. It's really hard to do like a direct comparison between the two because they charge for somewhat different things. Yoink. So PlayFab here, we can just roll down to party. I suppose this is actually relevant as well. The matchmaking requests, you will generally, for an indie title, never hit these limits where you're actually paying for something. I don't even know how small of a percent of a penny that this is per request. But that just keeps from, DOSing Microsoft servers. So here are their actual server pricing. And look at price sheet. View pricing. Okay, so the way PlayFab does it is they just have VMs that you kind of rent out whole by the hour. So you'll have some that are 1 core, 8 gigs of RAM, 50 gigs of storage, and you can't adjust that. So like while you're testing, you might just have 1 or 2 cores of this like AV2 instance here. 2 gigs of RAM, 20 gigs of storage. They do actually charge you a Linux license, which is the 0.437 hours, which is about the same price that Unity charges you for Windows. That's something I didn't actually realize. That's interesting. But yeah, so PlayFab might end up being more expensive for you or less expensive depending on your actual game needs. If you're just running like a Hearthstone style card game, you don't really need fancy CPU or a whole lot of RAM. So you could get away with one of the super low end CPUs here. Or if you're running like a 200 player battle royale, you might need one of these big boy servers. And they tell you what all types of CPUs that these are running, from AMD up to the Intel's Xenon. But I haven't actually went deep on the pricing here. I know the last time we talked about PlayFab and I ran a server for a week, I believe it may have been 2 weeks, racked up a bill of like $70. And that was with like nothing running on it, I believe. So again, for Unities, you don't get to choose like what type of CPU you're running, but they do charge you kind of a flat rate per core. And billing is done once a month, so they just charge you for what you've used that previous month. The scale testing and yeah. So back here in the setup, you'll want to keep this as low as you can. And basically what this comes down to is, running your server basically locally and then just checking your metrics and just see how much memory you're using, what your CPU usage is, and just scale this accordingly. For this test, it doesn't really matter. No one else is actually playing this but me, so it's going to be one server regardless. So you can just set this up to be whatever, like 100 or is the lowest. Because it has to be at least 100. 100 here, and yeah, we can do that and just see what. Then we'll finish. Or maybe not. Cubic 6. Six. Okay. Then we will create our fleet. So our fleet is the actual number of servers that we can potentially spin up for our game. Fleet name, whatever, test fleet. Windows support is coming soon. So you can only have, one fleet per region. So if you're deploying to other regions, you'll have multiple fleets for this. So your minimum servers available. When you go like into production, you'll want this to be at least one server, just so one server is always ready for you when your players decide to play. I'm leaving this at 0 because if I'm not playing it, no one's playing it. I don't want the servers to be running and racking up money for me. Max servers, I'll just leave it at 1 because it's just me. But yeah, this will actually spin up those extra servers for, for the demand. There we go. And then finally, we just create a test allocation, give it our fleet, our test fleet, America, our build, our test. And we can run the test. And this is why you want to always keep at least one server running when you go live in production, because it does take a minute or two in order to start up and allocate a server. So if your player is sitting here in matchmaking to play a game, they might think something is broken. So while that is starting up, we'll take a look at the matchmaking. I think I'll have to leave that right. Okay. Dashboard. Yeah. Okay. So the matchmaker. Um, this is kind of a companion, I guess you would call it, to the lobby service, where the lobby you could have like a list of matches that's being played and pick one that you like and join it. The matchmaker is more of an automated thing. You have different queues that you can queue up for. Those queues have rules that will match people up accordingly to those rules. So this would be more complex than, like, for your lobby, you could just do a quick join and just join the first lobby that you see that has an open player, and then you pick and choose it and go. The matchmaker, this can match through different criteria like map types or skill level or team composition, things like that. And those are all done through queues and rules and pools. To that. Nope, still waiting. Just look at a queue. Okay, so these are the queues that the GitHub project are looking for when you do a match queue. So there's a competitive queue and a casual queue. Your queues just have a name. Your queue name needs to be referenced in your scripts. We'll go over that here in just a second. You have a match players per ticket. So this is basically your match size. So if your game mode is a 5-on-5, then you would have a 10-player ticket, and then this will match up 10 players with 5 people per team. You have pools, which are kind of a subset of queues, which your pools can be like map type or could be for game type. So if you have capture the flag or team deathmatch or whatever, those could be different pools in the competitive queue. And the pools they have a timeout. So if it doesn't find a match in a pool after 30 seconds, it will default back into the main default pool, which should have like everybody in it. So if your pools are too restrictive or not enough people are playing in them, you can still fall back to this default pool. Each pool has rules. So for this, these are basically match types. This is just, I call it Slayer for free for all. So each pool, this match definition, it has teams. So for a free for all type game, you'll just have one team, which is where everyone is on. And that's basically it. If you wanted to have a Team Slayer or Team Deathmatch, you could have two teams, and then you'll have a player count for each team from 1 to whatever. There is also a relaxation range here. So after a certain amount of time, you might not want to start with a full team. So maybe you start with 4 players instead of 5. And that way you can at least get the match going. Then at that point, they have what is called a backfill ticket that will be opened up by the server to match up anybody else who wants to join in late. They will match up with that backfill ticket and then get dumped into a game already in progress. Some game types you don't want to have a backfill. Like you don't want a battle royale type game where somebody is joining in fresh in, the last 5 minutes of the game. That's not cool. But if you're in like the pre-lobby area for that, 5 minutes before the match starts, you could have a backfill ticket that will fill up that match in case anyone leaves during that pre-match time. I think we can add extras. So you have this like logic builder, which is, kind of the graphical interface here. There's also just the raw JSON. So this is what an actual rule looks like for the server. It's just a JSON little blob here that has, the teams, counts, and the match rules. These match rules. I guess we can just edit. So this would be optional match rules. So you could say, what would be a rule? You can have like a skill rule, right? Like true skill or ELO, right? ELO rank. That's the hotness for rank matches. So we can say greater than. Right, so our source will be data. I'll show how to add custom data to your players when we get into the code here in just a minute. This will just be rank. And we could say average. Right. So we can say like the average rank of all the players' rank should be 1500. Right. So then this would be like a ladder bracket, right? So this could be like our bronze tier would be this. We'd have another queue for the silver tier or the platinum tier or the gold tier or whatever. But I don't want to do that. Cancel that. And our server may have just broke something along the way. All right, so yeah, that's the basics of what a match definition is. We'll look at what a ticket looks like when you actually request one. Check the docs. Matchmaker. Okay, so these are basic examples of different match types that we have here. Logic examples here. So here we have a file for a battle royale type game. So for the match rules, we have a skill and also whether that person is a cheater or not. So this would match all of the cheaters together and everybody with a certain amount of skill together as well. We also have our team. Since it's a battle royale, there's only just one team, and it won't start until we get 50, and our max is 100. This is what a ticket sample looks like. So your client would pass this over to the matchmaker. You have your player authentication. This will be your actual authentication token, not necessarily your player name. And then you have your attributes. So this was just a key value pair of string and object. Your string is the actual name. This is what will show up here. Player's custom data skill. And also your cheater value here. This can just be literally anything, just any object. So any of the value types. I don't know if you can actually pass like structs and stuff to this. And this is the same thing, but with backfill enabled. So with this enabled to true, it will automatically create one of those backfill tickets. So the actual match can get filled up. This file here has the relaxation types. So after so many seconds or minutes or whatever, it will start to relax the player count requirements, just so you don't sit in matchmaking queue forever. After so many seconds, this one is like after the youngest ticket is 30 seconds old, it will start to drop this minimum player count to be something lower. So with the matchmaker also has some quality of service attributes to it as well. So this is just like your ping times to the various regions. So the matchmaker will automatically try to choose the region with the lowest ping automatically for you. But you can also just straight up tell it which location you are in. I haven't messed around with the quality of service stuff, mainly because I only have one region right now. But this would be what you would use if you want to show like connection ratings, I guess it is. I don't think it's just straight ping. And some errors. So yeah, I guess it does give you latency and packet loss. So that's good. Good to have too. So let's take a look at our actual servers. We have our two builds. We have our fleets. They are both online. I don't need this one. So we can just take our fleet offline here. All right, and that is okay. Yeah, probably our allocator is still tying up some things there. And we can also look at our servers. So these are our individual servers here. We've got 7 for our match fleet, 7 for our test fleet. Here, and then you can click on the actual servers. Did a little bit of testing on these already. Yeah. There is a certain number of crashes here, but I think that's just because I don't think the server is stopping correctly in the actual code. Yeah, we can see some of the events here. Yeah, I think just the deallocation here counts as an error. You can also check out our logs. This one here doesn't actually have any logs. Okay. So let's look at the actual code here. All right, so the way this works is we have a bootstrap scene for both the server and the client start here in this scene. And basically what the bootstrapper here will do is it will look and see if this is running as a client or as a server. There is quite a bit of code here, so we'll blow through this real quick. So in the editor, we have our editor application controller. Yoink. So this is where parallel sync comes in real handy. So it can actually just look and see if it started as a server or as a client, and then it will instantiate a server singleton or a client singleton accordingly. That is this here, this argument here. If it has this, start a server as well as for a client. And also if it's just the regular client without a clone, it just starts that as a client. All right. In our, close that, I did. Okay, like I said, we have a server singleton and a client singleton. We'll go through the server first. And what this will do is when this launches in, if it's a server, then it will instantiate the server prefab. Then it'll go into our server manager here and create a server, load it up with some of our default values here for our matchmaker to look at, and then start our game server. So here in our game server manager here, we will give it some default values here that will later get populated with the allocation service, which we have here as a separate class. The MatchPlay network server, this is the actual netcode for game object server that's going to run, that actually has our actual server logic in it. We don't need to go through this at all because that's kind of irrelevant to both MultiPlay and the Matchmaker. All right, so the first thing that it will do is it will start this when a server is started on the MultiPlay side. It will first try to get the Matchmaker payload from the Matchmaker service. The Matchmaker service is, yeah. So what this will do is this tries to create a ticket with our user data, which we populate from, we'll see the actual UI for all of that. We pick a map, a mode, and a matchmaking queue. Then we click on our matchmake button. This will go through here and tries to call the matchmaker service create ticket. And this gives a list of the players that we saw earlier in the docs, the authentication and ID, and then our ticket options. The ticket options is just the attributes that we saw, like the skill and like the cheater option that would be in here. This is all optional. And then what we do is we basically wait for the get ticket async. So after we created it, we actually loop through every second, I believe. There's actually a rate limit on how fast you can call the matchmaker. And basically, we just loop through this until we get a status, whether it's canceled or timeout or whatever. We basically call this get ticket async every second. And that will eventually get us a match, or it will time out. Once we actually get a match, then we have a result, and then we have the assignment message. And the assignment message has all of our IP and port information in it that we will then give over to our server. So this pick game info, which I think actually in this code doesn't actually do what it says it does. What it's supposed to do is it's supposed to pick the first, or it's supposed to find the most popular game preference and then run the server with those. What it's actually doing is looping through all the players that it got from the match, and basically the last one gets chosen as the map and the game mode. I suppose this should be like adding up and getting like whichever one occurred the most in said matchmaking queue. But that's whatever. So this is where we get our map info and our game mode. We will end up passing this back over to our server here as starting game info. Here in the start allocation service, we will, where is it? Here. Here, we actually get our server from the allocation service, which should be spun up and ready for us to use at this point. We will get the server name, player count, max players. All of this stuff here is what we get from our matchmaking payload. We tell the allocation service about these. So for additional like matchmaking or whatever, this will show up in the allocator so other clients can know about them. Then this will also like start the backfill if that is chosen there or not. And so here, this is the allocation service. This will actually start our matchmaker. Here. This is actually part of the server loop check. So when a server is available and running from our servers here, you'll have a server that is online, and then once we join a match, it'll be available. Actually, we can just go ahead and we'll do it later. So this will loop through, and it'll basically stay in this server check loop until it gets an allocation request, at which point it will here wait the allocation ID. As a matchmaker, you won't ever actually get this part because the matchmaker already has the allocation. So down here, this is just more debug stuff for when we actually get the payload here. We deserialize it as JSON, spit it back out, and then this will be returned back to the actual game manager to start the server. These on MultiPlay allocation, on deallocation, error, and dispose is all part of the server callbacks. I don't think I actually do anything with the deallocation. But these are things that are called back automatically by MultiPlay themselves. Okay, and then after down. So we've gotten the allocation service. We've started the backfill if need be. Then we start our network server open connection. So this is where we actually start the network server, which is our actual NGO game server here. Nope, this is the client. Here is the actual server. Yoink. Open connections. We get our IP, our port, our starting game info. We set our connection data here, and then we actually start our server. I believe right before we called open connection, called configure server here, back in the server manager. I think I skipped over that. No, after we do open connection, then we do configure server. Configure server is where the actual scene gets changed to our server scene. Here we call our network manager load scene manager. We get our scene name, load it. We can subscribe to on complete. Yep, a server data network variable. Don't actually do anything with that. And then we instantiate all of our game items and whatnot. I think we actually start the player gets spawned here. No, at that point, the server started. This is getting a little bit into the netcode for game objects part of this that I said I wasn't going to do, but here we are. So whenever a client connects to this server, it will go through this approval check. And it has a approval request and an approval response. This is where your player will get spawned. So our payload here is our actual player data. So this will be our player name, the color of our player character. And I believe that's it for the payload. So basically it gets encoded as a byte array. It gets sent to us. Here we get the actual byte array, encode it back into a string. From that string, decode it from a JSON. We test and see if we're already logged in for whatever reason. We have a dictionary for all of our players that are connected. If we're already connected, we disconnect the old one. Here in the response is actually where the character actually gets spawned. So we have to give it a response approved of true in order to actually connect. We tell it to create the player object. We give it a position and a rotation. And then we have a little task here that will set up our player. That part doesn't really matter. But we do have a name and a client network ID, which is the actual network ID of the player in question. So we just give it our username. If you just want to see it, that's how that's done. That's fine. We have our disconnect stuff. We have some send messages. That's fine. Okay, cool. On the client side, man, I said this was going to be shorter. I lied. On the client side here, we have what is going to be our user player for the matchmaking. This is going to be our name, our what all is in match user. We'll have a GUID, a name, and a map preference, game mode, game queue. Oh, I guess color is just random. And our authorization ID, which I guess we'll look at that here. Just a second. So, how you actually authenticate in the authentication services in DevOps. Come on. Super quickly here. For Unity authentication, it does not have first-party authentication. You can't log in with a Unity account, but you do have. My OpenID is new. You do have Apple, Google, Facebook, Steam, and I guess OpenID now. That's really cool. That you can log into if you don't want to just log in anonymously. But for most of what we're doing and what I usually will do, we will log in anonymously, which just has I think this is a hardware ID is what it actually tags off of. So with this profile here, this will create a new profile for a user. This profile suffix is what we get from, I think this is coming from ParallSync as well. So each clone will have its own unique profile, which has its own unique authentication. If you didn't do this, then every time you logged in from this computer, you get the same authentication key. So it just thinks you're the same person, which is good for like mobile And I guess VR, if you don't want to type in passwords all over the place, it will just automatically assume you're the same person. You also always have to authenticate one way or the other whenever you're using any of these services, Matchmaker, MultiPlay, or otherwise. Okay, so we have, we'll create a network client, Matchmaker, blah, blah, blah. We will authenticate. And I think the Matchmaker is actually what will begin start the client here. Here we go, and get match. So here, all we need to send our Matchmaker to matchmake. Matchmake is not a verb. Is just our user data, and our data is just our profile name and the match preferences and all that good stuff. Here, in our actual Matchmaker, we grab our user data to ticket rules, which I think is just not doing a whole lot here because they added all of this to the actual player. So this is where you would put additional attributes here. So if you wanted to put in multiple maps, like say you had a big team battle maps array of different maps that you would like to play, put that here, different map rules, whatnot, whatever you wanted to match for your rules. So your different rules that we had in the Matchmaker could key off of these attributes for this ticket. For this one, we're not using any of the attributes because we tied it all into the player options. So we don't actually care. We're not using these for actual matching. This is just going to be basically just the queue name, which we add in here, which is our user game preferences queue name. And then after this, we will again create a ticket with our players and our options, which basically none. Then we loop through, get our tickets again. It's basically the same way that happened on the server side, but this is on the client. It loops through every second until it either times out or gets a match. So returning the match results here, we get a IP address and a port. This is what we'll end up passing back to our client. Start. Here. Now I forget where our matchmake is. But anyways, after we create our match, then we go in and start our client with the IP address and the ports. We connect. I think that is super high level, everything that kind of happens here. So let's test. Check our servers. Sure our queues are active. We get our matchmake fleet demo. 30 seconds. That's fine. One thing that was surprising about this project is that it is using the new UI builder for its UI, which is neat. Probably need to jump back in and show how this is all done. But it is basically, we did a little bit of preview of this a while ago, over a year ago, I think. And it's basically a CSS style web dev approach to doing UI. But not the topic of what we're doing. So here's a matchmaker. We can connect locally if you just want to test, or we can choose our map mode and queues. Here we can change. We only have two scenes, whatever. So we can just hit matchmake and clear out everything there. Clear. What is matchmake? Okay. And we'll see how this goes. This is our user data. We have our randomly username. This is our authentication ID here, and our game info that we'll be passing to the server, our map, mode, and queue. Polling. This might time out because our server not yet online. And we errored and timed out. That's fine. Let's try it again. Starting our client. We did start our client. We did connect. I am not quite sure what happened here. Our other person did not spawn. Try that again. No, our backfill is not running on this one, so it is not going to connect back to this player. So if you look back in our servers, we will have 2 servers running here. This one is probably the one that's active right now. This one is probably trying to find a 3rd person to play. So let's disconnect from this one. And then try this again. And well, this did start. It's just spinning up more servers. So now we have, this just might be old. Now we have the 2 servers are available. Hey, there we go. But yeah, so now we have our 2 matchmakers. Let's see if we can get onto a different map. Space, meditating. Do competitive meditating. This works. Yeah. And here we have our server info. Meditating. Space meditating competitive. So yeah, that's the basics of running a server and matchmaking. I guess it did go about an hour and a half. And yep, we are allocated for the 1 server. So yes, that's it. If you guys have any questions or whatever, feel free to leave them in the comments or hop on our Discord. I'm sure there'll be more videos of this type in the future. Hopefully when we get our Tilt 5s in, I really want to do a multiplayer networked Tilt 5 board game thing if we get one in time, we will definitely checking that out. Check the overview. Matches. It might take a little bit to start piling the concurrent users. But yeah, that's it. So thanks everybody for joining us, and we will catch you next time.